Hello there, my name is Ahmed. I'm professional software engineer and founder. So as you can see on the screen, automation trust protocol, and that's the topic of this video, right? I just want to discuss with you, I'll showcase to you a solution to a problem that I think is very interesting, right? And that problem basically originated from our emotionally driven decisions that started with agentic AI, right? And I spent a lot of time deeply thinking, rationally deeply thinking about how we can approach this problem. So while everyone was approaching automation as a solution, I approached it as a problem, and I think I found something very interesting to showcase to others and possibly get other much smarter people than I collaborate, and we can ship a production version of this draft, right? So as you can see right here, it says automation trust protocol. So the purpose of this video, I said again, just to get the idea to the people, and we're going to spend this some minutes giving an introduction, the full specification, it's the Git repository that has also the demo that was implemented based on that draft specification. And why we're all doing all of that, as I said, uh, shipping a production protocol for automation requires a lot of people, right? Requires a lot of people, a lot of minds review it, and that's how we have amazing protocols, HTTP and other protocols that we have in the tech industry. So let's just discuss for a few minutes the solution and the problem and the solution. And after that, I have prepared a quick demo for you, implementing that draft specification that I came up with by myself, right? So let's just start explaining. So I'm gonna, as I said, we're gonna go into the demo shortly. But for now, let's just close all these tabs. We're gonna go through the code as well. Just let's expand this so we can explain things. Okay, so we have this, right? Automation Trust Protocol. What do we mean by that? Uh, let's take it by word and just explain it. And every word, why are you gonna start with the protocol? Because the protocol is gonna lead to trust, and trust is gonna lead to automation, right? And yeah, so we're gonna start here with the protocol right there, and we're gonna say, what are we gonna say? We're gonna define what a protocol is. A lot of people think they know what the protocol is, but they don't. So what is protocol? Protocol is a set of rules that govern something, right? So why we need those rules that govern something? In that case, what are we doing in automation or whatever that thing is, right? So it's a set of rules that govern something. And the reason we need set of rules that govern something, the reason we need specification and set the standard, because we noticed confusion, right? And confusion is a state of mind anybody can get into, and it's really bad state of mind. When people get confused, their brain is foggy and they don't make sound judgment, and based on that we're going to see failures and other issues. So to help you understand, solidify, I hope you understand what the word protocol means now, but let me give you an analogy or an example. So let's take, for example, authorization. I hope I spelled that right. So we have authorization here, right? So if I ask you, what is authorization? Authorization is like, it's easy, right? So who can do what? So authorization, we can say who can do what, right? So we are in the world of protocol now. Let's just explain it further. That sounds simple, right? Who can do what? Let me confuse you, because that's what's happened. People get confused. Let me confuse you. So, like, what do you mean who can do what, right? Because from this question, you can drive another question, right? I can be philosophical and I say like, who's who and what is what? That's a valid question, right? If I said that in a meeting, I might get fired, right? But I'm not trying to make jokes here. This is a really valid question, right? Who's who and what is what? Why are we asking this question? Because if you said who can do what, okay, we defined the who. Let's say, for example, admin. Admin is very ambiguous word, right? I'm gonna build an authorization system, and who can do what? Admin, right? Defined. Okay, wait. Before you can define the do what, right? Let's define who, right? Let's just give him roles, right? Let's give him roles. Like admin by itself is not enough. Is it a super admin? Is he a regular admin? Is he, right? We need to define it further, right? That's what I meant by who is who and what is what. And after we do that, like, we can define what. For example, manage users, right? This is the what. So when you say what is what, we mean what. What is what? We mean what? I'm serious. I'm not trying to confuse you. What is what here? This is manage users. Okay, what they can do is managing the users, right? This is the out. This is the outcome of the what. So we're gonna say here can do what? Manage the user, delete, update, create, and more action. We define the action, and that's get us to RBAC, but that's not the topic. Or attribution, role-based access control, or attribution, based access control, or whatever that is. But the core idea I try to explain is when we put a concept, right, for discussion or for implementation, people get confused, right? Let's just get an emoji, caveman emoji. I like this emoji. So what happened is when you select authorization and we defined it, right? People get false sense that they understand what authorization is, and uh, based on the meetings and blah blah blah, what's gonna happen? I confused, I smash, right? And the output based on that, based on I confused, I smashed, we go like to different teams. You're gonna see the different type of authorization implementation. So basically, every team is going to create authorize a custom, right? And that leads to people reinventing the wheel for one, and for second, that leads to security issues. Authorization is very sensitive, right? We need to nail it down. So based on that, what people decided, people like much smarter than you and I, we want to eliminate the chance for you to get confused, right? So we introduced to you OAuth 2.0. We introduced to you RBAC. We introduced to you API, attribution based access control, and so on, right? And the reason we introduced OAuth, why? Because as we said, we want to eliminate confusion, right? Confusion. I think I spelled it right. We want to eliminate that, and how we can do that by specifying the rules that govern authorization, and that's was what OAuth 0.20. And OAuth 0.20, why people trust it? Have you ever thought about that? Why do people trust it? It's because of the trust boundaries of OAuth. Let's just put the rectangle here. So basically, OAuth, what it did when the people who worked on OAuth 2.0, why there is not rectangle? Okay, I see it. Let's just put here, just this is the trust boundary. So what they did basically, OAuth 2.0 didn't reinvent authorization. It just defined the trust boundary, something people can trust. So you want to implement authorization with a third party entity. Okay, third-party service. Let's do client credential flow, for example, right? OAuth 2.0 client credentials, right? Let's do this flow, right? Client credential grant. So why is that? Like OAuth says so, and you don't trust OAuth 2.0, right? Everyone in the industry trusts OAuth 2.0, and the reason is not from nowhere, right? It's not from thin air. The reason people trust OAuth 2.0 to implement authorization is because it's better tested, right? And defines the trust boundaries very well, right? And that's that we spend a lot of time here because it is very important. And that brings us to our next word, right? As you see, like trust boundary we talked about. Now we're going to talk about what we're going to talk about trust, right? The word trust in ATP. So what do you mean by trust? As we said, we want to define trust boundaries. What are those trust boundaries? How we can arrive to them, right? uh, we can arrive to them by defining a protocol, and that's the whole purpose of this video, the whole purpose of ATP, right? Because as I said, I approached automation as a problem, not as a solution that people use today. So why are we doing this? As we said, we want to define the trust boundary because trust is a very important word, right? I want automation. When I want to implement automation, I want trustable automation, right? I have businesses, I have customers to worry about because trust is very important currency, right? The reason it's very important because once you bleed out trust, right, you cannot regain it again. It's gone, right? And that's very important. That's why we call it automation trust protocol. So how are we going to achieve that? We're going to talk about it, but let's just take it word by word. And now let's just go to automation. So automation, a lot of people think automation, let's just put automation, it just means we have steps, automate steps, right? So we have certain steps and we want to automate them. And that's the tip of the iceberg when it comes to automation. Tip of the iceberg. A lot of people don't know that. And that's where the core problem lives when I came up with this solution. So I noticed me, not just other people, even like top executive in top tech companies, um, they are confused about automation, right? A lot of people nowadays confused about automation, and the reason is agentic AI and the distribution power that just confused a lot of people. So what is automation exactly? What do you mean by is just automating steps? Is just using machine execution to automate steps? Is that what automation is? Of course not. Of course not. Because the reason is very simple. The reason is very simple. Let me give you an example. So let's say you want to do automation, AI automation, right? Let me just show you how a lot of people are confused. So AI automation, how are we going to approach that? So surprisingly, a lot of people nowadays use LLMs, agentic, let's say agentic automation. So a lot of people use agentic automation mostly for execution, right? But LLMs, we all know LLMs are really great at what? Interpretation. Did I spell that right? I think I'm just making a lot of mistakes. Yeah. So interpretation right here. This is what they're great at. And when you ask someone like what kind of agentic AI automation you have done this year, we're gonna keep this down here. This is an example. This is the demo, I think. Just take this, all of this here, right? So how are we gonna do this? It's tell you, okay, it's easy. I'm just gonna take an AI agent and give him some tools, and that's it. You see, there is a problem here. Why there is a problem? Let's just delete all of this. Um, there is a problem here because automation is more than that. Automation is more than that. And that's why I thought a protocol like automation trust protocol, ATP, is very important because there is more to automation than just that, right? And what we mean by that is just taking those words, right? So we have predictability, and we also have the word observability, and we have controllability, right? And we have accountability, and we have recoverability, right? And back to the example with AI automation that people think today, like they're doing automation with AI, when they give an agentic AI set of tools, that's it, innovation. No, this is like how to say. I think this is, excuse me to say, this is. I don't know why a lot of companies doing it. We're talking about companies that have billions of billions. Like this is the best you can come up with, right? What is your resources? Why you fired everybody? What's going on, right? Because this is not automation. Like the only thing that when you take an AI agent and when give it some tools, you're not doing automation. You're doing argumentation right here. Argument. This is a very difficult word. Let's just Google it. Yeah, you're just doing argumentation. This is not automation. You're basically crossing your fingers, right? Hoping that based on an intent, your agentic AI will give the user accurate output from cross domain knowledge. This is gambling. You're gambling with your users, and your user base is gonna disappear faster than Nokia when the iPhone came out. I'm 100% serious. I'm not making jokes here, right? Output based from cross domain knowledge. That's what they're hoping for. And this is argumentation. This is not automation, because from these 5 words, what this achieve? Nothing. Nothing. Zero. I'm 100% zero. Why? So like let's say predictability for a specific output input intent. Give the user accurate output. No, it's not going to give you accurate output if you just have set of tools to an agentic AI. You don't control. You have no control. You can put layers and layers and layers. to increase your luck. But at the end of the day, what I'm saying, what I'm trying to say is your automation pipeline is probabilistic, not deterministic, right? And you just basically not doing automation. So that's the core idea. So when we want to do automation pipeline, for automation to be complete, especially with agentic AI, because AI automation is not something new. I don't know why people are losing their mind about it. It's been here for a long time. What people excited about is LLM, agentic AI. And 99% of the cases I saw a lot of people implementing this wrong, including myself, because the first project I have done is an assistance, right? It's the easiest project you can do. You just plug in some tools, right, and give a chat interface to your user, and that's it. But that's not automation, AI automation, right? So how we can, what do we want the output of the automation trust protocol? Well, the output is based on 9 layers, right? That we tried our best in our demo and here in the back of this, right, to implement. We want to hit all of these. So if you looked at the industry currently, there is pieces scattered around, but none of the people currently implemented an automation with agentic AI that hits all of these 5 points. So that is not all of these. So predictability, as you can see right here, we want known outcomes for given input, and we want that 100% at the percentage of 100%, right? There is no gambling here. We have a very sensitive automation pipeline, and based on a specific input, as a business, right? I have a trust, right? We said in the beginning. You see, like why we use the word trust in our protocol, because I have customers that trust me, right? I'm not gonna sacrifice my trust because you think agentic AIs are cool, right? So I want to be sure before I even turn my head towards agentic AI, using agentic AI in my automation pipeline. I want to be sure 100% that the output is going to be predictable. And so far, the trust damage of agentic AI, AI automation got so damaged. Why? Because people are misinterpreting them and misusing them in their automation pipeline. That's why I thought coming up with a draft for automation trust protocol is very helpful. So that's the word predictability, and observability is very known word. You want full visibility into each step. If you looked on automation engines today, right, they don't give you that visibility. They give you visibility, but they don't give you full visibility at all, right? You just see a nice, let's take n of n and 8 of n, for example, because we're using it as automation engine in our demo. They give you a nice a nice UI, right? And you can see the execution, and but there is no, how to say, full visibility, right? There is no full visibility, and that's what we're aiming to do with ATP. And the third one is controllability. So a lot of automation engines today, they have observability and controllability, but not to the full extent that, or to the level that automation trust protocol is aiming to bring, right? And the word controllability is very important. Like, what do you mean when you say controllability in automation, pipelines? We say that we are saying the ability to pause or modify execution. If you looked at mostly all of automation engines, you cannot do that, right? So your automation engine will run the workflow, but you cannot pause, right? You can put wait, you can put custom node, but you cannot pause and then modify the execution, and based on that modification, another workflow happens. It's very hard to do, like for example, in A to N, you need a lot of custom nodes. You need to build those nodes to implement that. They have a lot of great nodes, but for that specific example, the controllability that ATP aiming to bring to automation is just not there. And the most important two is accountability and recoverability. So let's just discover those two. So accountability, what do we mean by that? So basically, when I create an automation protocol, right? When I create an automation protocol, I want to attribute actions to the right person. I want to attribute action to the right person. We're going to see, like here in ATB, our simple implementation, how the protocol does that. On just this is just draft specification, like from one person. Imagine like if more people tag along. So yeah, so we want accountability. Why? Because we want to attribute failures to the right entity. This is very important. For example, if like I have an agentic AI and I put a lot of tools on them, on that agentic AI, and I'm just building an assistant, and that assistant just told the user to do something very very stupid, right? Something wrong, let's say, and that person does this. So I'm not talking about the legality or whatever that is. I'm just saying who's gonna we gonna attribute this to. We're gonna attribute this to the note we put under the chat, right? Because it's like we put a note there. We are good people, right? We gonna should we see that note over there, just like we're not liable, and we're gonna find excuse for it. So this is not accountability, right? This is not accountability. You're basically saying I don't want to be accountable to the solution I put in production. And the only way we can do that, we need event-driven system, like fully event-driven system. We want to attribute every single action to the right entity, whether that's system, agentic AI, automation engine, a person, human in the loop, whatever that is. And finally, recoverability. This is a word that a lot of people get it wrong. So we want a mechanism to undo errors. So here, in for example, 8 of n, 8 of n of 8 uh, N8N. It's a great engine. So so they have a lot of nodes that help you with that. So for example, this node right here, trigger workflow, and another workflow has an error. This is not recoverability, right? This is not recoverability that we are aiming for. What do we mean by recoverable? So we want to stop the error before it execute. So for example, here, if this trigger happens, so this trigger happens because this trigger another workflow. What happens here? So when I trigger Argo CD rollback, right? What happened to the error over there, right? So I recovered here in the automation workflow, but I want to recover here as well. So this is a great node, right there, arrow trigger. So for example, I can just fetch, just get HTTP status, HTTP request, and just get the status of Argo CD for that specific rollback, and just do another automation workflow. So I know like NFAT to fin is not used, is not the typical solution used for infrastructure, but why not? It works, right? It works. So it's not the tool, let's say DevOps engineer master. There is other tools like Ansible and Terraform and whatever that to automate the infrastructure. But it works, so the solutions work, but that's not the point. The point is recoverability. So, for example, with agentic AI, let's say we created a humanoid that wipe the floor. That's the only task that the humanoid does, just wipe the floor, right? But surprisingly, I don't know what happened. In each case, he saw a mirror. The lighting was not right. The temperature was too cold, too hot. One of the sensors turned off. He just started smashing everything around it. Just smash, smash, like this, smash, smash, right? And you see, like how the recoverability word here is very important, and we put it in the middle because we don't want to recover from errors when they happen. We want to recover from errors while they are happening. That's what we mean by recoverability and undoing errors. So we want to recover from errors while they're having. And to be honest, I didn't nail this down very well with the word recoverability, with the specification. But the whole thing is here, right? The whole specification is here, and that's the whole idea of the video. Just get more mind attract to this. So now let's just get into the demo. I don't know how many time I spent explaining things. I hope I give you a clear idea. So here we're gonna just create a complex automation with ATP, right? We're gonna just build a platform, DevOps platform based on ATP, Automation Trust Protocol. So this platform, what it does basically, think about errors, right? When error, right? When a system fails, right, in production, most team what they have is just alerting, monitoring software, and that alerting and that system was gonna do basically is just gonna tell humans there is an error, And humans, the first thing is gonna do go there, like if they're really good, is just gonna go ahead and just assess the risk of the situation, right? So they can handle this very well. So we want to make this better. No, human. Humans not errors, they are human. So we're gonna go here and just try to do this better. We're trying to do this workflow. Let's keep it here. So what's the problem with this? Time, right? So when the alerting and monitoring, we don't have overall control much over here, right? But we have control here. So when that notification is sent to the team, how many people are on call, right? Are they gonna react very quickly? How long is it gonna take them to just to arrive to a workstation and start debugging the problem? You see, there is a huge time, and why this is problematic? Because a lot of problems in infrastructure, when they happen, they are just too simple, right? They're not risk critical. If your production breaking a lot, so if your production is errors a lot, so you have a problem, right? You have really big problem because production shouldn't break a lot. So then you have a good example of that for top tech companies. So you are rarely hear about system that's very critical going down, right? And that's because they don't want it to go down very often. They have SLA and they have customers, and their customers are enterprises, and that's fireworks. Okay, I thought something exploded. It's Saturday. What is this? Okay, so with that being said, so this is the workflow right here, and we're gonna go here and try to make it better. How are we gonna try to make it better? We're gonna go and do it in much better way than it has been done. Usually has been done. And how are we gonna do that? We're gonna implement ATP, Automation Trust Protocol. So we're gonna go from here, from the monitoring layer. You're gonna say, instead of sending this to a notification engine, what you wanna do, you're gonna send it to ATP. And ATP is gonna use LLM. You see how we're using LLM? We're not using it for execution. We could, but we're gonna use it we're gonna use it for something much better, which is interpretation. And here, this interpretation is going to be what? Risk assessment. Why are we assessing the risk? Because we want to know. We want to know, like, is this action related to dev environment, staging environment, low risk action that we can automatically do, or something is very critical, like the production. So we don't want to do automatic actions on the production, mostly, right? Mostly. There is a really great tool like, for example, continuous delivery, continuous deployment, like Argo CD. Argo CD, the issue with the normal Argo CD is going to roll back to the previous version. So if you want custom rollback, you need to use Argo rollbacks, right? And that's the whole case of why we're using LLM here in the risk assessment, right? Because risk assessment is very important layer in uh, in um, in ATP as a protocol, as draft specification for a protocol. After that, we're going to just go to the approval engine, and the approval engine is going to do an HTTP request with HTTP with HTTP metadata to what? To the execution layer, right? To the execution layer. So this is the original demo that I was planning to do, but I changed it a bit. But the same idea applies here. We're going to see how I changed it. So now we're going to jump into the demo right here and start showcasing to you ATP, the draft of ATP demos. So I took the ATP the draft specification, and I came up with let's say it's very simple demo to showcase the capability and what can we do when we have such a protocol, right? Okay, let's jump into the demo, right? Let's just go ahead and jump into the demo. Just discard this internal server error. It doesn't matter. What we're gonna do here, we have everything is going. I think it's working. Yeah, it's working. So what we're gonna do here is just start with the demo. So what do we have? We have uptime Kuma that hit the first workflow, right? And we have a dashboard right here. We just showcase, I think, quickly. And also we have an automation engine to implement ATP. And that's what ATP is all about, right? So we're going to have three of them, three of automation engine, and both of those, as you can see here, we have high risk workflow, ATP demo, and low risk. And low risk is just going to auto roll back a deployment, right? and the high risk is going to ask the ATP designed for accountability, right? So when there is a high risk, is the way we implemented ATP, we said any high risk action, we need a human. So what's the point? This is not automation. Well, we can use active and passive learning, like how AI automation has been done for years before LLMs comes to the market. After a while, after we collect enough data, collect enough action, enough human actions, the AI can make sound judgment, right? Can make sound judgment without any errors. And that's the whole core idea of ATP. So I'm not gonna jump into the dashboard code because it's just UI, right? So let's just see the functionality. So how did I implement? I tried as much, to be honest with you. I tried as much to implement all this specification, right? Squeezed my brain as hard as you could in the past few days, but I missed a couple things. I missed a couple things, but let's just see a simple demo. And this simple demo, in my opinion, shows the value of ATP as a protocol, right? So we're gonna go here and first of all, I want to showcase to you. We have, as you can see, we have how many components? We just have 5 components, right? And the first one is approval engine. Our approval engine is a very basic one, right? We're just gonna say if it's low risk, just system is gonna auto-proof this action, right? If it's medium or high, right? If it's medium or high risk, we need the human required right away, right? Because we didn't implement yet active and passive learning, right? And else we have a security issue. Call the security teams because where this risk came from, right? And the second one, as any really good AI automation system, we need the memory, right? We need the storage, and this storage does a lot of things, as you can see, right? First of all, it stores action because everything inside ATP is event driven, and the event that trigger everything is an action declared, and this action can come from anybody, from a human, from a system, from whatever that is, right? We didn't implement authorization authentication yet, just to keep things, how to say it, just to be able to ship it with a short notice. So here we have everything, right? The most important thing we have is risk assessment, which we're gonna discuss this component in a bit, which uses LLMs and agentic AI, and yeah, so we log in everything for accountability, right? So we can attribute every single action to the right entity. And this is the APT store, and the execution engine is a very simple one, as you guys, as you said, we're keeping it very simple. So this we have two workflows, as you can see right here, low risk workflow, and it's just very simple thing, right here, just to get the idea going. And we have a low risk workflow and we have a high risk one. If it's high risk, right? If this is a bug, you see, like I'm bug sniper. If it is this or medium, I need to use the models. I'm not using, yeah, I'm not, I don't know why I'm using, I'm using text, but that's fine. We're just gonna trigger high risk workflow using a webhook. So this is how our automation workflow is gonna be triggered. And if it's low risk, what we're gonna do, we're just gonna trigger the low risk automation workflow, right? And that's our execution engine. Very simple one, the most basic one you can implement, right? And second thing we have here is a very important component, and that component is risk assessor, because risk is very important layer within ATP. So tried my best to nail it down, and I think I did. So here we have the init method and here assess risk, and we have a fallback, and we have a way to explain the risk, right, in natural language for a human to review, and actually need human approval. And yeah, so we have an OpenAI key and blah blah blah. And finally, we have the verification engine. Again, I tried to keep this very simple. Currently, our verification engine is just how to say just just there is no checks, right? There is no checks, as you can see right here, and just get things going, just to help me finish this demo. And other than that, the approval engine is there is life cycles within everything except the verification engine. There is the life cycle is missing because I didn't have much time to complete it. And of course, like when you have a specification or a protocol, you need to define models and you need to define them well, and you need to implement that protocol or draft of a protocol using entities. And here we have the entities, for example, the action entity, action declaration, which trigger everything and blah blah blah, right? So here, if I went to the Docker, I have the dashboard here running, right? We just have one action declared, or it's two, okay, whatever. And so why this button is not working? Okay, so we have two buttons, two action declared, and both of them are high risk, right? So what I'm gonna do here, I'm just gonna trigger an action from here. As you can see, I'm gonna share this the collection. It has very simple documentation on it. So for example, I'm gonna trigger this high action. I'm just gonna go to send and wait for the output. As you can see right here, give it the LLM give it a really high score and give us explanation for that. And I forgot very important component here in the backend. And we have simple REST APIs that implement ATP. So here we have the risk assessment, great. And as you can see, if we went to here, and right there we just have the action that uh, we just put, right. It's right there, I think this one. So we can go to the details, right, and we can see everything. So here what we're going to do basically, let's just see those. So both of them 1FF, and what we're going to do basically here, we're just going to go to uptime kuma and simulate this workflow, uptime alert. So uptime alert here, what it's going to do is just expand this. So it's going to receive a notification from Uptime Kuma for the service, and it's going to use ATP to declare the action and check the risks of the action. If the risk of the action is high, it's going to send the notification, and the person assigned, the team assigned to this email is going to check the dashboard and see is going to approve or reject the remediation of that action that got declared. And if it's low risk, was our automation engine, what workflows was going to do is just going to auto do just some kind of auto rollback, right, based on that error. So let's just simulate an error here. So here we service is just def user service, and we're just going to click test and go to here and see execution. As you can see, it's running. Hopefully no errors. Yeah, there is no errors, and we're just going to check what happened. So here we just got the data and create an action payload from here, from this entity, and we use this action to send it to the ATP gateway. And based on that, right, we got a risk assessment, and based on the risk assessment, we decided we're just going to send an email, right, to the team. We're just going to send an email to the team and say risky action trigger. That's it, right? So logically, when this happened, right, what are we expecting with ATP? So we're going to refresh here. I think is 1FF is this action right here. The score is 85, is very high, and the action state is declared. So we're going to go to the details and see how ATP works, right? As you can see right here is full visibility, right? We have the context here of the action, and here we have the action metadata, and here we have the risk assessment. And the AI decided it needs a human review. After a while, right? After our AI have enough data, our agentic AI have enough data, I can do this. This high risk is gonna go lower, 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 and humans gonna have more time to do more important stuff, right? Even though there is a production, but after time, because as you can see, like a lot of errors in production sometimes can be repetitive, and you can stop them before they happen, right? And here it just says that approval request from CEO team. As you can see, everything is visible here with implement authorization or authentication. An AI explanation says overall risk score high. Key risk factor, production environment. It give it 40%. Action effect, production environment. Customer facing service. Yes, it makes sense, right? It makes a lot of sense. That's why I said that LLMs are better at interpretation, and most people use them for execution. And here, recommendation, a human review. So this actually requires a human review. So we're going to go to edit trial, right? Audit is very important layer in the draft ATB. I think, where is it? It's just like it's part of the learning and feedback layer, right? And this allow I think this is just yeah. So this is every action is logged, and this allows us to for in the future train our LLM on how to say fine tune it on our data, right? Based on these actions and how the workflows happen. So this is the audit trial for this action. Currently, we just declare it from uptime to coma because simulated a notification. And based on that, what are you expecting next is just we can reject or approve it, right? So what we're gonna do is not this one, it's this one. We're gonna do this. We're gonna do Ahmed known issue rollback, right? I'm just gonna approve. As you can see, we approve the action. And if we just refresh the page, as you can see, we can execute this action. So if we went to details, edit trial, AI explanation overview. Yeah. So here we have we approved the action, and we can view the full JSON. And yes, so as Ahmed said, it's known issue rollback. And the status update, we just gonna change the update. We're gonna change the action from approved to from wait. No, it wasn't approved. It was declared to approved. I don't know. This is a bug, but it's fine. As you can see, like it's full visibility, full observability as well, full accountability. Like we can attribute every single action that happened within our automation system with audits, right? And here what we're gonna do next is just gonna execute, and when we execute, we expect it to go to this workflow right here. Is a high risk workflow. So we're gonna go back to the platform right here and just hit execute, and we can ignore this. This is old one because the execution engine, if we went to the backend right here and just go to approve execute, it's going to use the executor, and the executor is just going to use its own webhook. This is not the right way to do it. Like in real life, you're going to need a storage, right, for these webhooks, and so you can be able to attach every specific outcome to a known workflow, right? But just for demo purpose, we did that. So we're going to just hit execute, and the action got executed. And if we went to details and the audit trial, historical consumer actions 1, success rate is 100%. Okay, this is for future, right? Because we can use active continuous learning here, and the system in the future can auto approve very high risk actions. They're not risky anymore. Why? Because agentic AI or AI knows how to do them. So here what we're going to do basically after we executed this action, what happened, the duration was less than a second, and the verification was complete, right? What we did, uh, again, this is simulated for um, the length of this video and also implementing the demo, but as you can see, it got triggered. This, I think, uptime no, high risk. So we're gonna go to execution just now. There is an error, that's fine. So we just want to check here. We want to check what? Okay, so this is our automation engine got this request, and the approval is Ahmed, right? And here we just triggered something, right? We triggered the rollback in Argo CD, which is very simple, right? It's just a token, credentials, payload, and endpoint. I didn't do it because I was short on time. But yeah, so this is the whole idea of. I was more excited to show how ATP work than give something perfect, right? And as you can see, this is ATP in general. The draft of the ATP. I have. I'm gonna link in the description of this video a blog post and as well the source code for this draft, and hopefully a lot of people get into this, and we can ship something. We can ship something great. That's very useful. That's very useful, right? And with all of that been said, thank you so much for watching, and yeah, see you.